Okay. So we're getting started with this talk. It's a short seminar on how to actually tips for writing a research essay, research paper. Okay, I'm doing it myself, and this is the result of some mentoring process that I did over the years, and also some European projects that I've been working on. So everything you hear from me today comes from my own personal experience as an author, so writing papers, starting with my PhD, and also as a PhD advisor. You can use it at your own benefit or risk, so disclaimer. And in what follows, so this is the approach about this talk. I will be using example from my own research. Okay, so you will see snapshots, like pictures of some papers that I published. We think that, in my opinion, are quite nice. They could be working fine, and I'm suggesting to you also as well. So this is the outline of the talk. Okay, I would like to spend a few words on what is the state of the art and why it, in my opinion, is so important and never underestimated. So this is about how to approach your research. So this is even more, it's not actually how to write a paper, but before writing a paper and before conceiving your next research challenge, think deeply about it. And this is about a few words about that. Then I go with the typical structure of a research paper by trying to have a section by section walkthrough and with suggestion on how to structure your paper and things that are generally working fine and things that you should be maybe avoiding. So we have all the section here, typical section like introduction, related work, system model, like algorithm and solutions, explanation of your scheme, algorithm, solution theory, and finally, usually we have some final section where you have results. They could be experimental result, they could be simulation-based, they could be mixed. It could also be a theoretical section where you explain some, some proofing to prove that what you did is correct. And then the conclusion. This is actually the typical structure of a paper. Then I have some random recommendation. Those are all of them coming from my own experience as an advisor, and those are things that I don't like when I see them in the papers, and also as a reviewer when you want to review some top quality journal or top quality conferences, and you see some of these things happening. Usually, I'm not very happy. So I'll tell you what you need to not to do or try to avoid as much as possible. Then some closing. So we start with the state of the art. In my opinion, is very important. It's a cornerstone for a good start of any research in the world. The common problem that I have seen as an advisor, and also myself, I also had this problem myself at the very beginning of my career. To rush, you have an idea, you rush and you go straight and you implement it without realizing that it was already done, maybe was already pursued, maybe slightly differently, but your research is not really innovating, right? Innovative. So what you're doing does not have like a high novelty. Maybe you are improving on some existing technique. Maybe you're doing even defined work in doing that with a very strong analytical component, like a lot of math. And this is what was my mistake at the beginning. So I had a lot of math, so I was working on a lot of macro chains and the decision trees and the decision theory, something like that. But the topic itself was not new. Okay. So in this case, you can come up with a very nice piece of work, very analytical, very well done. From a scientific perspective, it will be like appealing because you have all the theory laid down and all the theorems and the proof, but the novelty is very weak. And in this case, you may have a hard time in having it published because the work is derivative. So as a researcher, sometimes, especially at the beginning of your career, it is tempting to do so. To modify something that is existing by expanding it or revising it, but the work is not new. Be careful, because then it's a pain to try to publish, because the reviewers will have a very easy time in saying, okay, the analysis is fine, it's correct, even the theory is very cool, but the work is not novel. So rejection, okay? And I had this problem at the beginning, so this is like a heads up, just to say, this is quite common, especially at the beginning of your career. Try to be patient, sit down, search and read good papers before embarking in new research. Make sure that you have explored enough. Reading papers usually, hopefully, allow finding areas that really deserve your exploration and your attention, and allows you, hopefully, to spot missing and relevant research items. So this is actually spend 1 day or 2 days or 1 month more, but be sure that what you're doing has some potential in terms of novelty. Okay, and the state of the art, in my opinion, is very useful, especially for this. So the state of the art gives you awareness about the relevance of your research, the novelty of it, and the research topic, all the research topic. If you see the trend, they emerge, they develop, and then you see that in the curve of publication about a certain research topic, you see the number of papers published on that topic will be increasing like a bell shape, and then you go down, and you reach an end of life sooner or later for any research topic that I have seen so far. So the first thing is to understand, if you like some item, some research item, what is the status with respect to this end of life? Are we close to the end of life? Are we just at the beginning? Is just emerging? Are we in the middle of it? So be aware of this. Okay. Maybe it's not a good idea to start embarking in a research team if this is very close to, if this is close to end of life. Okay. Because by the time that you have something really and cool to be published, then maybe you need 1 year at least just to understand the background, the theory, and come up with a nice research work. And then by that time, nobody is any longer interested in that, and you will have a hard time to publish, because this is, again, not very novel. So try to contextualize your idea within the research field and see what is the status according to this trend, development, end of life. Okay. What I would like you to do is to start starting a research team very early on, soon after it has emerged, or even before, even in the very moment where this research team is about to emerge. This is actually difficult, maybe for you, but for your advisor, maybe who has more experience, it should be sometimes possible with a little bit of luck to identify something that in a few months or maybe will be cool, everybody wants to go and will be developing. Okay, sometimes we have signs, we can get signs, and then the thing is read literature, read papers to be aware of what is the state of the art, and also predict based on what is happening, what could be a cool topic for you to study even before it will be emerging. That will be the dream for everybody, for every researcher. Because remember that working always entails a cost. So try to use your time and to work on things that are promising, okay? Use your time effectively. So again, this is a repetition of the previous slide, but just to make it clear, knowledge, you gain it from the state of the art, provides you with a way to discriminate what is highly cited, but probably close to end of life. You don't want to be here, you want to study this. B, what is not yet very highly cited, but probably will emerge. And C, new things that you can do yourself to advance the state of the art. They are not already there, but they have high potential, okay? Try to spend time on B and C, okay, as much as possible. Again, a very good piece of work on type A may be difficult to publish because of lack of knowledge. Okay, this is just a first thing that I wanted to tell you. It's not about writing a research paper yet, it's about research design and conceiving your research topic. Now we stop here with this, and we start with trying to answer how to write a decent research essay. The answer is the only way is to write many, unfortunately. I found in my career there are no shortcuts. Maybe now with ChatGPT, maybe you have a few more chances than me. We didn't have that. But then I will tell you something also about ChatGPT, okay? So that is the end of the talk, probably. No, of course not. I'm here for you, but really write, don't be shy, and this is a learning process, and you need to do it to learn. This is a typical paper structure. The title, the abstract, introduction, related work, paper body, the main paper body. Then here we have related work. It could also be before the conclusion. You can decide whether to put it after the introduction or before the conclusion. Then you have conclusion and an appendix. Appendix could or could not be here, depending on the type of work. And yeah, we'll discuss later on that. The title is very important. It is the first point of access to your paper from a reviewer, from any other researcher who's browsing the internet to see look about a certain topic you would like to learn. So the title must be catchy, but this is my recommendation. Try not to overdo it. For example, this, you guys know this title, right? You can raise your hand if you know that. It's very famous. It became very, very successful. But I believe this type of title, I mean, it is very catchy and bold as a statement, but I'm not 100% fond of this way of behaving. In my opinion, you cannot solve all the problems in a single paper. It's all you need, right? So as a recommendation from me, show self-confidence, but not to the point that it may be perceived as vulgaring. So trying to keep it, strong, self-confident, but maybe possible approaches are a descriptive title and stating starting with an acronym like this one, millimeter trace IR. This is a paper that we did, and then we have the acronym, and then a sort of description of what we do with this technology. Or other approaches are describing the technique, for example, model-free radio map estimation in massive MIMO system via semi-parametric Gaussian regression. This is actually quite descriptive, technically telling you what you can do with this technique that we have in the paper. Or again, this is another approach, identifying the field of application, for example, mobility-aware and dynamic migration of multi-assets as computing services for the Internet of Vehicles. So this is actually pointing the finger to the application domain. Okay. All those things are possible. Take your time. Don't write it immediately, or you may have a tentative title, but do it at the very end. Okay. This is very important. What I do, I start sketching titles and sharing, in overlays now with my co-authors, my students, different titles that I like. They do the same, and again, informally we decide, okay, this is the best one, and we modify. But this is very, very important. So please share ideas with your collaborators, and also get inspired by the title that you noticed and that you like. Okay, that is also a strategy. Usually the final title, we finalize it when the paper is complete. Also because only then, you know exactly. Sometimes when we start research work, we realize entirely, fully, the value of what we have done only after finishing the write-up. Because during the write-up, there are things that reveal, maybe since you're writing, if you're spending time explaining your technique, you may be forced to look into what you did from a different angle, just because you want to explain better to the reader, right? And maybe you realize that what you did has even more potential than what you thought, okay? So the title could be changing in the process, okay? It's very important. The abstract. Also, this one has to be written at the very end. This is my suggestion. The abstract is a short paper on its own. It should be concise, but very meaningful and very well written. It is the only part of the paper that the reviewers and the interested readers will probably read with attention and fully. If you don't succeed to capture their attention here, they will probably continue if you do capture their attention, otherwise they may skip your paper all at once. They just say, okay, the answer sucks. Let's go on. Let's see a little bit this figure, this one, no. And they don't review your paper carefully, right? This is my feeling. Okay, this is what I also has happened to me sometimes. Okay, so I can tell. It has to be a mini paper on its own. It is just maybe 250 words. Sometimes you have limitations. Must be self-contained with no abbreviations. Must explain the problem state concisely but effectively. Must explain the relevance and uniqueness of what you propose. Must state that what type of contribution you're presenting. If it is theoretical analysis, experimental work, mixed, okay. Must report at the very end of the abstract a brief performance summary to emphasize the effectiveness of your technique, proposal, theory. Recommendation. Also this one, I write it at the very end. At the beginning, I sketch it quickly, and then we go over it all the time, a few times, okay? During the paper write-up, what I do, I annotate aspects that emerge from our study that maybe we were not aware of before writing the paper, and then it becomes important to emphasize them in the abstract because we realize that they are, quite interesting, okay? And so it could be a particular perspective, a way to present your technique, a particular type of result, or the reusability of what you're doing for within a different field or application. So this is something that you may realize during the write-up, and you can write it in the abstract. That's to show that what you did is actually relevant. It has potential. So here in the abstract, you need to clarify the main selling points without overselling, of course, of your work, and the usefulness to others, other researchers, even implementers, or people working in the industry or what you do. It is better to annotate these things when they emerge during your write-up, during your collaboration with the other students, because it may be that you then it's difficult to recall them at the very end when you need to write it. So annotate, have them there, even in a sketchy format, doesn't matter. But you have them ready for the final abstract. Also, better not to define acronyms in the abstract. Okay, you do that in the main paper. This is one paper that we published with my students, and there are many. This is an abstract. And you can go and read it at home. You will have the recording, so you can go step by step and see what I mean. So we start with the scenario, like 3 lines. So here we set up the application domain. So this is what we're doing. We are dealing with social distancing and temperature screening, maybe for COVID-19, and with ICT technology. Okay, we set up the scene, the scenario that we are dealing with. Identify the drawbacks of prior art, and without, of course, being respectful always. Okay, it's just a technical statement. You need only. It is not about your personal opinion. It's about technical statement. Okay, this is important. So here we say, while no solution have dealt with these aspects separately, their combination is not yet so common in the literature, right? So combining these 2 aspects that we are talking about, social distancing and temperature screening. So social distancing is basically with radar technology to measure the distance between the radar and the target, but we want to jointly also measure the temperature of the person. Okay. So we have a system that is combining these 2 aspects together, and this is the first time that, according to our literature review, that we are implementing and showing this operating system that we propose in the paper. Then, after identifying the scenario and the need for this, so the drawbacks and the lack for this technology in the literature, we move on with here with the explanation of what we do. This work presents, then we have the name of it, and then we say what we do and we say join a millimeter wave base, so this is identifying the radio spectrum that we are using for that, so millimeter waves, as in the previous talk. Together with infrared imaging sensing to perform unobtrusive and privacy-preserving human body temperature screening and contact tracing in indoor spaces. Okay, and then we say also technically. So this is what we do at a very high level, and then we go down at a deeper level by saying how we do that. We have a sensor fusion approach, which is robust somehow, and then we will tell why it is robust. Involving millimeter wave radars and infrared thermal cameras. We achieve fully automated measurements of distancing and body temperature by jointly tracking the subject faces in the thermal camera images and the human motion from the radar system. And then, after saying what we do, we state the achievable performance of the system. So here we detail what this system is capable of. Technically, again, the type of precision in the distance estimation as close as 0.2 meters. So we can identify, we can pinpoint people that are as close as basically 20 centimeters, right? So which is a very good number if you know about radar sensing, okay? And also we say for the temperature, maximum errors of 0.5 degrees Celsius, okay, for the temperature estimation. Moreover, we are also able to provide contact tracing through highly accurate 95% accuracy person re-identification in less than 20 seconds. This is a complexity consideration. I didn't want to talk to you about the technique. This is not about, is not the seminar about the radar sensing, but just to exemplify a typical structure that I like, okay? And I believe most of my abstracts are like that. So number one, you set up the scenario. Number two, you identify missing points in the literature. Number three, you're stating how you deal with those missing points. Number four, you present the technical details, some technical details, and the achievements, quantifying as much as possible a few performance indicators of your proposal. Okay. This is another example. This is about a data set. This is a paper, a recent paper where we published a large data set for Wi-Fi sensing technology. And again, the same structure is a little bit different because, of course, the aim of the paper, what we are selling, is different. Okay, you need to adapt, but the idea is the same. First, number one, we describe the reference scenario. We are talking about a repeated Wi-Fi infrastructure for sensing, human sensing in indoor. Many machine learning algorithms have been proposed to do that, to monitor human movement from Wi-Fi channel readings. However, and here we go with we move immediately into the problem area. We describe what can be improved, and what is not right, or is not available with currently available technology or solution. And then we describe what would be needed, what is needed to compensate for that, right? And then finally, we describe what we do in the paper and how we entirely or partially fill the gaps that we have identified through what we do in the paper by providing technical details. And here, the technical details that we provide are the number of channels that we use for the Wi-Fi network, how many channels are sensed, then also the frequency domain, what is the bandwidth over which we operate, what type of 82.11 technology we use for the experimental measurements, and also we describe how to use the data set for others. So this is a paper where we are selling the data set to the community. Okay. This data set was awarded and was uploaded in the IEEE data port, and we got the prize. It was awarded as the best data set in the competition in I would say probably December 22. Okay. So it was quite successful. And then we have the data set in data form, and this is also a good place for you to publish your open data. Maybe we're gonna have another seminar on this, but yeah, publish the data, publish the code. We discussed that later on. Okay, and then this is about the abstract. Okay, then we move to the introduction. Keep it short, usually 1 page maximum. Similar suggestion as for the abstract, be concise and to the point. Possible approach, so those 6 points are not the only one, a possible structure for the introduction, okay? Start with a brief introduction to the research technology area, 1 paragraph, like a few lines, 3 or 4 lines, emphasizing the importance of this area in general. And also the importance and the novelty of this research domain that you're about to talk about in the whole paper. You don't want to work on something unimportant. So it needs to be important, and you need to show that this is relevant for science, society, you name it. Okay, you need to have it in the first 3 lines. Again, you identify the scenario and the importance of the scenario in the very first paragraph. Don't make it too long, but you need to have it. In every paper, you will find something like that. Number 2, go straight to the point. Identify the scenario and the problem that you solve with your proposal, with your work. Again, stress the relevance and the importance of the scenario, if you can, and of your work. Never overdo. Okay, it's very subtle. There is a subtle line between overdoing and stating these things. Okay, you need to be quite technical and precise, but at the same time respectful. Is a subtle combination of And I believe by reading papers you will understand how to manage this. Then you may discuss the limitation of you need to discuss the limitations of existing work, if any. If no prior work is available, very good. You are the first one, and you need to state it. Don't take it for granted. Don't assume it. Don't assume that the reviewer will know that you are the first one. You need to say that. This is to the best, and in order to be humble, usually we say to the best of our knowledge. No prior work is available on this topic. And in this paper, for the first time, we develop this and this and this, okay? This is very important. So this is actually solving so showing that the work is novel. Number 4, use the references you need, no more, to stress the relevance, originality, and cite the most important prior art. From 3 to 10 references are usually fine for an introduction. Remember, the introduction is not the state of the art. The state of the art goes in the related work section. The introduction is a place where you need to state what you're doing to frame the research that you're proposing into a broader domain, right? To identify, to contextualize your research, and to cite the relevant papers to show that what you're doing is not derivative, it is novel, it is very much needed, okay? And in the introduction itself, you may have as well have an indication of what you write in the abstract. So you may say also here a few words on the actual performance that you achieve. So it's like a repetition with respect to the abstract, which is okay. The abstract is there, but then in the introduction you can repeat some of that information. In this point here, number 5, what I do always nowadays. I wasn't doing it in the past, but nowadays I do it in almost every paper. I use a bullet list to review the novel contribution is a summary. After you have your introduction and you say what you're doing, say a little bit about the literature, the novelty, what you're solving, why it is important, and then what I do is I have something like this. I have a a paragraph like this, the main contribution of the present work is a summary, you know, to summarize, if you want, the main contribution of present work, present paper are, and then you have a bullet list, enumerated. Number 1, we do this. Number 2, we do this. 3, 4, and 5. And usually in number 1 and 2, we say high-level information. So it's a joint system for an obtrusive and privacy-preserving human body temperature screening and contact tracing, and we designed the system and we implement it. Then we have a novel data association algorithm is proposed to robustify. This is very technical. The tracks obtained from the millimeter wave radar and from the thermal camera, where the radar returns the people coordinates and the thermal camera identifies the people faces in the thermal image space. The achieved precision and recall in the association are very high, 97%. We have also a new clustering algorithm for this, which makes it possible to resolve the radar reflection from subjects that are as close as 0.2 meters or 20 centimeters. Then we have a new, this is a machine learning based algorithm, the one based for person re-identification. Okay, so, and also this one is trained at runtime during the execution of the algorithm itself, and is able to identify previously unseen subject, achieving an accuracy which is also very high. And then we have a novel algorithm to perform the temperature estimation of the skin, especially in the face portion of the person, and so on and so forth. And also in this case, we stage the errors for the temperature estimation process. So this is maybe it will be changing from paper to paper, but the idea is always to have a bullet list as a summary at the end of the introduction of what are the main contributions, the main technical contributions that you're proposing here. The first bullets on top are more high level. You're saying this system is doing this and that, right? Solving this problem. And then the next bullets are becoming more specific on the type of algorithm and on the type of technology that you're devising and on the performance that you're achieving. Okay? This is working very well. And I have it almost all the time nowadays. Okay? And at the end of it, this may or may not be here, is a paragraph where it is customary to have it. You can remove it if you have problems of space. Typically in journal papers, you're going to have it. And this is telling the reader, look, the paper is organized like that. In section 2, we have the related work. Section 3, we have some basic concepts about millimeter wave radars and thermal imaging systems. So this is like a background review sections to provide some background on the technology that we are going to develop, because maybe the reader is not aware fully of this technology. So we want to help the reader. Section 4, we have the approach, which is thoroughly presented very carefully. Section 5, implementation is described, and then we have the performance evaluation with real experimentation set up, and concluding remarks in the final section 6. Okay. Okay. Here, what I wanted to do with this slide is you need to discuss the limitation of existing work in the literature, if any. If no prior work is available, I said it before, I repeat it, state it explicitly, because this shows the novelty, okay? The take-home message from this slide is that you don't have to assume anything from the reviewer. Don't assume that the reviewer knows the map that you're developing. Don't assume that the reviewer knows the field, and even that what you're proposing is novel or not. Don't assume that the reviewer knows already that this is the first time that something is proposed. You need to state it. Okay. Also, nowadays, this is also something that is working pretty fine. What we do with my students, at the beginning, we have a diagram like that, which is you see, is a mixture of, we have some figures, some some humans walking, and the distance now is 2 meters. These are experimental points from the radar, and those boxes here are basically what the camera, the thermal camera, is detecting the phase, the position of the phase, right? So in a single image like that, what we do, we exemplify the functioning and the operation of the whole integrated system that we are going to develop and explain in the paper. But we anticipate with this image the capabilities of the system. And we say, look, with this system, if we have people in an environment, we are able to detect reflections, radio reflections from radio signals from the body of the bodies of those people, and the radio reflections are we get them to the radar device, right? And those are the reflections that are basically identifying the location, the position of the person, and possibly also the movement. Okay. Then we are able to identify the position of the face through the thermal camera, and also the temperature estimated from the thermal camera, right? And we are able to detect the distance between the persons by looking at the center of the body center here, and looking at the distance between the two. We are able to identify the people involved, ID 1 and 0, so each person will be receiving a unique identifier in the system, and if you move from a room to the next room, your identifier will be maintained, because there is a machine learning algorithm that, based on the shape of the reflector and the behavior of the reflection from your body, will be identifying you wherever you go. Okay, so once we are able to track a person to get the ID, this ID will be maintained as long as the person is within the building, potentially. Okay, this means that we can track continuously the temperature of this person, the behavior of this person, and so on and so forth. So with a single figure like this, we are able to describe the capabilities of what we design. Okay, and we found it very appropriate to have it, because this is helping the reviewer to understand in a better way your proposal, because the reviewer will be exposed with a graphical illustration where you see some experimental points and some exemplification of how the system operates. This is not for the purpose, it's not a commercial. It's not for the purpose of selling your work. It's there for the purpose of clarifying as much as possible what you do, and have a reviewer understand what you did in the best possible way. Okay. Nowadays, I also see papers that are taking a similar approach, but instead of a technical figure like this, which is there to explain what you do, they put like something like a commercial, like by emphasizing the performance, emphasizing how cool we are, and so on. I don't like those things. I see there is a line of work that is following this path, but I don't like it at all. Okay, it's like a figure which is there to sell the work. Okay. This is not there to sell the work. It is there to explain that. It's a subtle difference. Now we go to the related work section. Wow. It will be taking longer than expected. If you want, I can stop, and then if you want me to continue, we can go on until 1 o'clock maybe. I don't know. If you feel it useful. Related work section is not always needed. What we do, we have it always for journal papers, because we have space available for that. Okay, so for a journal, it is recommended to have it always. It could be after the introduction. Sometimes it's right before the concluding section. Okay, depending on the style, depending on how you want the flow to develop. Okay. For conference papers, we don't have it, because in some conference paper, you only have 6 pages available, depending on the type of conference. So in this case, what we do, we have a mini related work inside the introduction. Okay, this is the approach. Okay, for journals, I find it better to use a separate dedicated section for the related work. The typical length for the journal papers and major conferences is 1 page. I wouldn't do it longer than 1 page because this is becoming a little boring, right? You need to focus the attention on the really important papers that you from the literature, not on every possible paper. Otherwise, it becomes a survey. You don't want to write a survey. It's not a survey. I mean, you can also write a survey, but it's a different type of paper. Also, the approach, try to write it by carefully reviewing the work done, by expressing, you don't need to express your personal judgment. You need to express technical, provable facts about the literature. The drawbacks should be provable from a technical point of view. It is not you judging the work. I don't like it, I do like it. It is you stating whether the work is effective technically, the type of performance that is possible, whether it can be improved, whether there are major drawbacks that can be fixed, okay, that are provable, because the technology maybe has to be improved, okay? And this should be based upon technical facts, okay? Important for each research paper or group of papers that you are reviewing here in the related work, you need to state what they do, and also in maybe 2 lines are enough, but you need to do that. Emphasize the advantages that are brought forward by the current work and proposal that you're proposing here in this present paper. So the idea is review the state of the art, and immediately after saying in the present work, we improve this aspect by proposing blah, 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 through an algorithm that compensates for blah, 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 okay? And you need to consistently do it. So every time you're reviewing something in the related work, you need to add maybe a couple of sentences or even a single sentence where you state what you're doing. In addition to that, what is the aspect that you are fixing or solving or improving with your current solution? This is the purpose of the state of the art, to show that you are aware of the most recent literature, to show that you are improving and what you are improving it, okay, and how. Also, if I see a related work section with all the papers from 91, I become suspicious. Maybe the author is not aware of the latest trend. Maybe it's impossible. I mean, we publish millions of papers every day. It is impossible that. So if there is no work which is more recent, you need to state it. Again, don't assume anything. In the literature, we didn't find more recent papers, or you need to state that. But then again, if this is the case, I become suspicious, double suspicious. Maybe the problem is not important, so nobody's looking into that. Maybe it is so novel that you're the first to think about it, but then you need to convince me, okay? So this section is when I was younger, I used to write it very, very quickly. Literature, I was reading every time, all days. I was getting rid of that and then focusing more on the algorithm aspect that I like better the math and the algorithm. This is like boring, but unfortunately you need to make it right. The same thing applies to the introduction and to the abstract. Paper body. Let's say for theory papers are papers that are mainly analytical, a lot of mathematical models. Maybe a good idea to start with a section with the mathematical preliminaries, okay? Then to continue with the system model. Also, what I find very useful, if not necessary, often you're developing your idea. It's a new algorithm with a lot of theory behind. You have it in your mind because you've been working for 12 months on that. And when you explain it for you, it's so trivial. It's so logic, right? But it's not for the reviewer. Remember, the reviewer will be reading for the first time your complicated algorithm, and it will be a mess for him or her to understand it. will be very difficult. So what I try to do also with the student, what we're trying to do is to come up with a toy example and before explaining your solution in a full-fledged, very complicated and complete fashion, we give the toy example that to provide the basic intuition behind the solution and your design. Okay, so the toy example may be it is there to explain the main rationale by using a well-accessible, often simplified, crafted model that is there to convey the general idea, right? Maybe your idea is working with any number of users, but for this toy example, I'm using 3 users. Maybe it's using different priorities, but maybe any number of priorities for the packet, for the flows. But for this example, you're using only 2 priorities, just to exemplify and to show the general tracks and the general idea and key point behind the design, and then you can extend it. And this is working very well. Because at least my mind is working like that. I try to understand better, I usually understand better when someone exemplifies something. I'm sure that if you provide a formal description from the beginning without explaining the idea, the core idea in a simpler way, it will be very difficult for the reviewer, even though it's correct, right? Pay attention to this. When you do that and you explain it properly, then you can explain how to generalize it. And by the way, this is our contribution, and now we go with the full-fledged theory and so on and so forth. So you go progressively, right, in terms of complexity with your explanation. Use a table with all the mathematical symbols in the paper. Again, if you only have 6 pages, you cannot do it. But usually for journal papers, the number of pages is sufficient, and it is highly recommended that you do so. Okay, we do so. Use diagrams, as many as you need, to exemplify the system model. In the diagrams, what you need to do, you need to connect the model variables with the system components and with their functions. I'll show you now. So this is an example of a background section. This is section 3 in this paper that we submitted recently, and we have like a notation. It is also a good idea to provide a background section, technical background, where you start with a notation for the whole paper. It's about matrices, I don't know, some transforms, the norms, and so on and so forth. And then you don't need to show the muscle. It is here for clarity. It should be concise. It is a place where the reviewer will go back to just to understand how matrices are defined, how sets are defined, and so on and so forth, if you have a mathematical oriented paper. Then it is after this section here, it could also be that you need to go through some review of existing mathematical techniques. This is like a mathematical background section that you have there just for kindness for the reviewer, so that you don't need to go through the whole theory. I mean, this is what we did, is maybe 1 column, right? But just to show that there are some main equations that we are exploiting. They are developed within a theory of compressive sensing. We state the general results of compressive sensing and the general idea behind it, and then we use references to compensate for what we cannot touch here. Okay, but it could be a good idea to have like a background section on the math that you need to develop in the paper. This is the beginning of the system model, and as you can see, we start with the general setup and assumption. So we say, okay, this is our system model. We have a network of devices. Those devices are mobile edge computers, and we have end computing devices that are part of a communication network. Each node is device, and we say that it's contained within a set of nodes. It is equipped with energy harvesting, like a solar panel, a local computation unit, a CPU, and communication capabilities It is equipped with energy storage device, so a rechargeable battery, and can generate computational tasks, which are referred to as jobs. Then we divide the nodes into two categories, and then we continue with the system model and with the assumption, what we assume, and so on and so forth. And this part here is about explaining to the reader the setup. Okay, the nodes are like that. Those are the capabilities. This is the stack containing the nodes. They have CPU, processing, communication. Okay, and then we continue with the subsection A, B, C, and so on by explaining each aspect about those nodes. For example, here we explain how the energy is accumulated and maintained within each device. So we have a buffering process occurring. So the energy expenditure is basically coming from the CPU processing or for the communication process, and the summation of the two is providing the total energy in a time slot. Then we also have some energy harvesting occurring. Energy harvesting is pushing some additional energy to the battery. And we explain mathematically these things using variables and also diagrams. We have a table of symbols. So this is one full column. And here you need to specify all the variables in the paper, in the analysis, the meaning of the variable, and the unit of measure. Use units of measures. Specify the units of measure in the table and in the plots, please. Okay. Define units of measure. The table can even take a full column. I recommend you to add it for journal papers. I would also add it for conference papers if space allows. Well, diagrams. There are many ways of generating diagrams for your papers. I'm not going through a lesson on the tools. Now I have a few recommendations, but it's not my role now to teach you how to use the tools and which tool to use. This is just an example. This was from one of my students who said, okay, look, lately PowerPoint is becoming quite powerful and it's capable of generating diagrams that are very good quality. You can do your diagram for a scheme, like the nodes, energy harvesting, transmission process, and so on and so forth. And then you can also, but in this diagram, what I want to do, I would like those variables to appear because I want a diagram that is using the same exact variables with the same font that I'm using within the analysis in the LaTeX, in the paper, right? So how can I do that? Because PowerPoint is not capable of dealing with LaTeX symbols. It's not natively capable of doing that. So what we did was to install Iguana, and yes, you can install it, and this is a plugin for PowerPoint. I did it with my Mac, but I'm sure that you can also do it for Linux. And in this case, you can basically, you see in this plugin, you have a window where you can write the LaTeX code, and then you compile it, and this will be appearing directly into the slide as the equation, right, that you need. And here, in this case, you can have the exact LaTeX symbol that you are using in your paper. You can use it together with your PowerPoint drawing capabilities to have your diagram done, and then you can export it in PDF, for example. And this is working fine. This is a very quick way of achieving high quality diagrams. So I wanted to share this with you. It is not the only one. It is a very quick and efficient way of doing it. Maybe not the best one, but you can do that. Okay. Possible programs is not exhaustive. I did it last night. Okay, I'm sure there are more. You can use PowerPoint, as I explained. You can use OmniGraffle. This is an exceptional program. I've been using it for a long time for Mac OS. The problem is that you need to pay for it. So maybe you're not in the position of paying. I did pay for it, so I think it's very good. You have Rovio. This is also allows you to work collaboratively by creating diagrams over the internet. Inkscape, I don't like it, but you can use it. XFeed is very old. I've been using it when I was in my PhD in 2004. It was the whole time, but it's still quite, you see what you get. Graphical interface, it's a minimal graphical interface, but very effective. You can directly use the LaTeX command by using this library. Take that library. Or you can use a visual graphic editor to create some LaTeX code in TXAP that will be generating the diagram for you. In this case, I've been finding a few tools over the internet that allows you to draw the diagram and then to export it in this LaTeX, in the LaTeX comments that are understood by this library that take that. Okay, so you can have it as a native piece of LaTeX code to be embedded in your thing. This is quite nice to have it embedded in this form, because if you need to change something about your diagram, even a symbol there, you're changing the naming for a symbol, you don't have to redraw it with Iguana, PowerPoint, or maybe OmniGraph or other things, but you just go to the LaTeX code and you change the corresponding symbol and you're done. You recompile it and you're done. You understand? This is an example. For this one, we have been using, I believe, we've been using this library, TXAP, and here you see the all the symbols are exactly the same symbols and the same let's say the same calligraphic fonts that we use in the LaTeX, in the main text. Okay, this is what I want to see. I don't want to have an E here or an I or K. Maybe you have some Greek letters also that appear differently from the same letters and symbols that you're using in the main text. This is hard. This is not professional. Okay. And here, what we do here, we use this thing, this diagram, we use it together with this section where we explain the system model. And step by step, we explain all the blocks that are contained in the diagram by explaining the relation between the blocks, how the energy is distributed, how the energy is loaded, or arrives, or is basically consumed by CPU or radio blocks, how the data traffic is managed, how the computing is managed. Okay, and we use this to exemplify the relations between all the blocks and also all the map that we develop in terms of system model. No fancy diagrams. Simplicity is best. Black and white and symbols. Use the same symbols as in the rest of the paper, embedded with LaTeX, possibly. Okay. Diagram example number 2. In this case, we use this diagram to explain in the results section how we perform the experimentation work. Okay, how we collected the data, right, from the field. And we have been using no fancy diagram also. In this case, this is actually the planimetry of the indoor. So you see we have couches, maybe here we have I don't know, some desks, some bed here even, because those are real indoor environment. Like this is a living room, this is a bedroom. And with the numbers, we are basically showing, and with these letters, transmitter and receivers are the position of the access point, the Wi-Fi access point that we have been moving within the environment to collect this information. What we collect is channel readings, the radio frequency information from the environment, and we collected that through those Wi-Fi routers. Also, we have been using a color code. You see, we have the green, like here is pinky, thingy, and a bluish. And with the color coding, we use it because then in the text we explain that in the blue area we've been experimenting. I don't know, with the user performing jumping and running, for example. In the green, the user was sleeping and maybe in the pink part, the user was maybe working at the computer on the desk, maybe like that. Okay, but we use the color coding to effectively communicate what we did within this experimental environment. Okay, how we used the space that was available. Okay, for experimentation and design-oriented papers, and a good example for me is this paper over here from 2018. So up to now, what I did was to discuss a little bit the system model and how to develop the theoretical model for papers that are mainly analytical, or where you have an important part of the paper which is about developing mathematical model of the system. What we do now, we consider papers that are not analytical, but where you're developing an algorithm not based on theory, but based on your own ideas. And then this is an experimentally driven paper, let's say. And the approach here is slightly different, right? And what we do here to explain the solution that we will propose for this type of paper is to have a first section, the first technical section 3 in this paper, for example, where we describe the processing pipeline. In this processing pipeline, we have a diagram of the solution, of the flow, the processing flow that we have been devising, that we are proposing, okay? And what I do in this section, I have this diagram, and then I have a high-level description, view and description of the technique of all the blocks and algorithms that are conceived and that are used within the diagram, right, from left to right. So basically here I'm describing at a very high level how the system that I'm proposing is going to operate, which are the blocks that are involved, why they are there, what it is their function, and how they interoperate. This is very high level. I'm not touching math, I'm not touching yet the detailed description of the algorithm. Then, after this section, I continue with the detailed explanation of each one of the blocks that I have identified by using separate sections. Okay? This is the signal processing workflow. You see we have different blocks. This is actually data coming from a mobile phone. So we are measuring accelerometer and gyroscope signals from the mobile phone, and we do signal, is a lot of signal processing we go through, and each block has a different functionality. In this first section, we present at a very high level the steps, why it is conceived like that, what is the main function of each block, so that the reader will have an idea. Maybe he doesn't know the details of each one of the components, but will get an idea of what you're doing and why you're conceiving this in this way. And then in the following sections, we have one subsection for each one of those blocks where we go into the technical details about the design of the specific block. Okay, this is a possibility. I've been using this since 2018. I've been using it for every experimentally driven or paper where I have a new design. I'm doing right now. So I have a first section where I have a high-level view with a nice diagram explaining the general grand picture, and then I go down into the details. This is another paper where quite recent, 2021, where we do something similar. In this paper, what we have, section 1 is the introduction, about 1 page, with the bullet list at the end, with what we do, as I have explained. Related work section, which is 1.5 columns, short to the point. Section 3, then I have a background section on millimeter wave radar signal processing, including a figure which is there to explain the main concept and capabilities of the system that we are inventing, proposing. Section 4 is the proposed algorithm. And the first subsection of this section 4 is an overview of the proposed signal processing pipeline. Once again, according to this idea, we are providing an overview of the full pipeline by explaining the main steps, why we do that, and the following subsection contain the algorithm, the details of each one of the blocks. This is the explanatory figure in section 3. So here, and what we do with this one, we are basically saying, okay, look, you don't know yet how this will be achieved because this is, you need to read the whole paper for that. But we anticipate that with this technique, you are able to extract this type of data. So if you have a radar in the system operating with radio signals, you can identify the people, here we have 3 people in the environment, and you can extract some features in this space, which is like velocity and range. So you're basically estimating somehow the velocity of the body parts of the people and also the distance between the person and the radar. You can do that for each person in the environment. You can do some clustering around the person to identify the center of mass of the person, so the position, and also the velocity of the limbs, like the arms, the legs, the torso, and so on. Okay? Or you can have a more complex representation where you have velocity, distance, and angle. So you can also estimate, if I'm the radar, I can estimate the angle between myself and this user, or myself and the lady over there, right? So the angle of arrival of the reflected radio waves that are coming from my target, okay? This is again an additional information that we can add, and if we do so, we have a 3D representation of the features, right? And we can also extract, at the very end of the processing, this one is a signature. We call it microdoppler signature, is a signature of expressing as a function of time the velocity components of all the body parts that are reflected off from your body. So you're moving, I'm throwing at you a radio wave, I'm receiving a reflected wave. In the reflected wave, I can, by processing the reflection that I receive, I can understand the relative movement, the relative velocity of your body parts. And this can be studied as a function of time and embedded in this sort of signature, which is actually representing the velocity in meters per second as a function of time of all the reflected points that I'm getting back from you. We are now used to see this type of signal. From this type of signal, I can understand whether you're seated, standing, walking, running, jumping, or doing other activities. Because according to the activities, this signature will have a different shape. Okay? Also, I can sometimes also reveal your identity because each one of us will be performing an activity in a different way. Even walking is not the same for everybody. Walking reveals your identity. It's a self-biometrics. So by looking at this, I can be able to detect your identity also. So we have a lot of information here. And now I'm not telling to the reviewer, to the reader, yet how to achieve this, but I'm showing the capabilities of the system and explaining what type of signal, what type of result you can achieve. And I do it in section 3 at the beginning here with this explanatory figure, just so that the reader will be aware of what this proposal is capable of. After that, I go into the description in section 4 with the flow diagram, where I go through all the blocks. I explain the general blocks that I have designed and how they interact and how the processing flow behaves. And then I go into the description of each one of the blocks in detail. Okay. This is what I said up to now is part A of the paper. Part A of the paper is title, abstract, introduction, related work, system model, and description of your invention, the description of the new proposal, system, algorithm, whatever you're proposing there. Then we have part B. Part B for me is the place where we present the experimental stuff or the simulation setup, depending on whether you're doing experimentation or simulation. The parameters that you have used for simulation and or experimentation. The experimentation campaigns, the measurements, how they were collected from maybe simulation or experiments. And the result, the performance of your system, okay? And the conclusions. This is part B. So a few hints. You need to present carefully the simulation experimentation setup, state the system parameters, do not omit the system parameter, please, because your results have to be reproducible. Make it so your result will be reproducible, so the state the parameters, eventually publish the data set and the code itself. So eventually is a false friend in Italian, so it doesn't mean possible. Eventually means you will do it with probability 1 in due time when the paper is published, but please do it with probability 1 sooner or later. Because we are sick of papers without code and without possibility of reproducing the research, especially experimental research. Nowadays, in some serious conferences and journals, they don't even accept the paper if you don't do so. And I think it is correct. My view. And try to explore your solutions from different angles. By trying to attack your solution from different viewpoints and show that maybe it's robust, maybe there are cases that is failing, but in some cases it's also good to show that you are aware of some of the drawbacks. You cannot solve it all, right? Sometimes. Carefully organize the material into subsections, one for each dimension that you are going to explore. Use graphs and tables, high quality graphs with confidence intervals. This is an example table for the system parameters. Units of measures are everywhere. This is a diagram where you're showing the experimental area for the measurement. Again, this is a radar system, so basically we are people started walking within the space. We have radiators, the windows, and this is a corridor, and then we are basically detecting the people while they are working. This is a snapshot. It's a picture of the environment just to show physically what we did. Okay, so that will give a sense of what we did and how you can use the system. And the idea was to localize and track the people doing the movement, and also to identify, to discover the identity and the action that they were performing. This is actually some results. So again, this is a window length, which is a parameter of the algorithm, and this is the accuracy that you achieve. You see that there is also a confidence. The shaded area here is basically revealing a region of confidence, which is actually information about the standard deviation of those. This is the average measurement, and this is the standard deviation of it. Okay, just to give a sense of statistical confidence for your results. Also, try to include an implementation section. It is becoming quite common. In this implementation section, you explain how the testbed was realized. The choices that were made to make everything work, they are non-trivial sometimes. And it is very useful to make the measurements reproducible. This is actually a paper where we did it in 2022, quite recent. And this is an example implementation section. If you see here, we say, okay, we describe the implementation on this SDR millimeter wave platform. So we made the implementation of this Wi-Fi protocol, blah, blah, blah. And then we describe the functionalities that we augmented in the testbed to enable full duplex operation, and so on and so forth. The parameter that we used in the FPGA logic that we've been using for programming this. Also the details in the estimation of the channel response, the channel samples, and all those things are implementation specific. With those things, and another implementer will be in the position of replicating the work with air or ESO testbed. Okay. Conclusions. The concluding section, I sometimes call it concluding remarks as a section title. Often, what we do also what I did a few times, is to write this section in a hurry. Okay, conclusion, done. The paper is already written. Now, conclusion, in this paper we did this and this and this. My solution is wonderful. It works incredibly well. And please accept my paper. Full stop. It is not the way. Conclusion, unfortunately, don't have to be written in a hurry. What I would like to see is to write a quick summary of the paper but just summarizing what you did is of little utility, okay? And maybe also a bit boring. It's just repeating the abstract, repeating what you see in the introduction, right? So what I recommend is to try to emphasize briefly the main benefit. So you can, 3 lines, you can say, okay, in this paper we did this and this and this, and we propose this solution, achieving excellent results. And then you try to say, these are the benefits of our work, of our solution. Say something that cannot be found elsewhere in the paper, something that may be useful, how to further improve what you did, extensions, for example, or how it can be used, or what you did can be used to solve other problems. Maybe if you see that, even in different domains, okay? Or underline aspects that are still open, even for future research, because you are not solving the whole problem in a single paper, and maybe some of the aspects are still open. Maybe I don't know, increasing the accuracy when there is a particular event happening in the system. But yeah, you need to be honest. So try to make it useful. Otherwise, it's a little bit boring. The annex is especially for papers with theoretical derivations. It makes sense to carefully organize your theoretical material so that the derivation will flow nicely in a logical and consequential manner in the paper. So what I tend to do is often in the main paper body, it may be convenient to present the rationale, also with toy examples, the main results, with proofs. And for the proofs, you can in the main paper have the discussion of the proofs, the general explanation of them, and also the statement of those proofs and of the result that you achieve through the proving technique. But then the technicalities can be discussed too, but the actual proof of those results can be moved into an appendix. So the mathematical proof itself can be moved into an appendix part, or even in a technical report if you don't have space, okay? And the technical report can be published to arXiv or some other public repository where it can be found, if it's too long for a single paper. Okay, this is actually the recommendation. Now we have some random recommendations that are deriving from the many papers that I wrote. Math variables and equations. When defining equation, make sure that all the symbols in the mathematical expressions are defined before using them. If I see an equation, oftentimes containing symbols that were not defined before, I get a little bit upset. Okay? Cannot do that. You need to define the symbols, the variables, their meaning, and then you need to use them. You can use them only then in the equation. Okay? This is a common mistake. Pay attention to clearly define all the variables. Do not take anything for granted. Again, try to think about different naming alternatives for the variable. For example, if t is time and I is an index related to the position in a vector of the elements in a vector, all those things can be possible, right? Maybe even more. Try to use the simplest, use it consistently across the whole paper. Don't change the notation, please. And try to use a notation which is actually quite accepted also in the literature, in the main books, in the reference books about the topic or field, right? A notation which is, in my opinion, this one is rather cumbersome. It's not really convenient. I would tend to use something like this maybe or like this for a vector, or even this one maybe. Use the one that is simpler to catch in an equation. Okay? From the reviewer or from the reader point of view. the one that is simplest to read and understand. And then, once the notation is selected, use it consistently. For all the vectors, use the same. Okay? Equations and LaTeX. Pay attention to the alignment of the equation. There are LaTeX commands and environment for aligning equation and defining equation across multiple lines. You want to number each one of the lines in an equation or not? Depends. I usually number only what I need to reference. So whenever I need to put a cross-reference to an equation, then I need to have a number. Not necessarily I want a number for every equation if I'm not using it. But for sure, if I have a multiple line equation, usually I tend to have a single number associated with all the multiple lines, right? Unless I need to refer to a specific line inside this equation, then I have a number for each. So don't overdo with the numbering. This is something that makes me upset also because it's a matter of attention and the degree of cure and commitment that you're putting into the breakdown. It is very easy to write minimum as min like that. For the minimum, maximum, cosine, sin, tangent, arcmean, exponential, diagonal, we have special LaTeX commands, and this is what it should be appealing, never what we see on the left-hand side, okay? If you write min in an equation, you get this. To have the correct min, you need to write backslash min, because there is a specific command in LaTeX to have the min operator, okay? And this is what you're getting. So this is showing me that immediately that you have no knowledge whatsoever of how to use LaTeX for technical writing and equation writing, okay? And I tend to, when I see something like that in the equation, I tend to say, okay, this guy is just started. Okay. He's at the very beginning, he has to learn. Let's see what he did or she did here. Okay, I'm already skeptical about all the rest. Maybe it's a bias that I shouldn't have, but it is happening because I see that this is not the correct way of expressing the equation. There are functions and commands for integrals, sums, sets, both sums, matrices, vectors, and so on and so forth. Use them professionally. This is another example. I have equation 19. Okay, and we have sets. We have this gamma, this I think a W or omega, I don't see that. Anyway, those gamma, omega, they were already defined before. So the meaning of this is, when I go here and I look at equation 19, what I would like to see in your paper is that all the relevant variables like S, R, gamma, omega were already defined before, prior to showing equation 19. So this should be the case, first of all. Oftentimes what I see is the cost function is boom. And then later, after defining the cost function, maybe even much longer than this one, which is already compact, the author is telling me the meaning of all the terms. No, I want the meaning of the terms to be defined before, so that I'm ready to understand your function when you show it to me, okay? What I can do, what is acceptable, is this. The penalty factor, this is a cost function, becomes, boom, where these are the weights that can be arbitrarily set as a function of R. They were already introduced, but then now here I specialize them by saying, for example, we can set them equal to this function here. Okay, I'm specializing the general weights that I defined before, even in the prior part. Okay, this is what I can accept, just specializing one of the variables for this specific use. Okay, but the general meaning should be defined before. Equation 21 is an optimization problem. Look how nice it is. This is a very complex optimization problem. We have a cost function to be maximized as a function of x, which are the control variables, and gamma is defined here. This is another minimum, which is a penalization factor. Anyway, this is your cost function. Actually, it's the reward function because we want to maximize it, so it will be a reward. Anyway, subject to 1, 2, 3, 4, 5, 6, 7, 8, 9 constraints. Okay, what can happen sometimes, I'm sure that you've seen something like that in a paper. They say they write this problem by maximize this subject to, and then here they put all the constraints written down explicitly, right? This makes it like a very big optimization problem, which will take half a page probably, and it drives me crazy because you need to go through it and start, you're batting your eyes and you're saying, okay, what is it? What is this constraint? And then maybe they explain, or maybe they don't even explain, they constrain one by one. What I prefer to do is, before doing this, you basically, in different subsections, you analyze each one of the constraints and you present it in detail and you give it a name. You call it equation 2, 4, 3, 6, 7, 9, you give it a name, okay? And you analyze it before. So that the reader at this point will be ready to receive this complexity. Because you need to maximize this cost function, good, because I have explained it before. I told you the meaning of it by subject to all the constraints that we have already discussed, that are already formally defined in the previous subsection, okay? So you don't have to write down the huge mathematical problem and then trying to explain it all at once. You understand? I'm sure that you have seen something like that. It's terrible. Maybe some could even do a good job with the full problem, but look, it's scary. When you see something like that, and it's okay, I need to take a week off. Okay. Punctuation. The equations are part of the text and must be punctuated accordingly. So basically here, I need a comma because this is a sentence. The penalty factor of interest becomes gamma, comma, where those are the weights, blah, blah, blah. For example, by setting gamma equal to, comma, with those parameters, they penalize the scheduling solution as they allocate, blah, blah, blah. Full stop. Accordingly, the optimization problem is rewritten as, in this way, full stop, because you're ending the sentence here, okay? Use punctuation for the equation that you have. They are part of the sentence, okay? Bad quality graphs. Wow. Avoid using PNG or JPG graphical material. Always use graphical material saved in vector formats, which is encapsulated PostScript or PDF format, because they are scalable. If you look at the quality of a PNG or JPG, as you zoom in your paper, you see all the pixels, right? You see that it's becoming awful. I don't want to see that. If you do it with a PDF saved graph, you will see that the quality is preserved. No matter how big you make it, okay? How you zoom in. The graphs, for the diagram, there are a lot of programs to realize high quality diagrams, and export them in PDF, for example, is a good approach, okay? Again, scalable vector graphic. For the graphs, you can use different solutions. GnuPlot is a line command tool, hostile. I've been using a lot GnuPlot during my PhD. It was very good. It's for like Linux or low-level programmers. So it's all command lines. So I was doing, distributing jobs over cross computers and having this, what you call it, batch files that were computing things for me, running simulations and doing things, measurements, and then I had a bunch of those scripts that were computing the graphs for me for all the results in the background. Okay, this is still very it produces very high quality graphs in EPS, encapsulated PostScript. The bad thing of it is that you need to know the language. You need to write the scripts that are read by GNU block. So you're basically injecting those scripts into the GNU block, and the GNU block will be taking your data and will be generating automatically the output file, which is a beautiful, if you are able to have a nice script, could be a beautiful graph in vector form. Okay, and you do the advantage of that is that all command line, you don't even need to open the graphical interface. You can automate it with all the things that you're doing across computers. Okay. But of course, you can also use MATLAB and you can also use Python, and they are offering excellent ways of processing your data and achieving very high quality graph, okay, plots for your data. A recommendation is to check MATLAB to TKZ and also TKZ-plotlib for MATLAB and Python respectively. Those are tools for converting MATLAB figures into the LaTeX figures in TKZ, right? For example, so for native inclusion into the LaTeX document. So what you're doing, you're generating a figure with MATLAB, which is a high-level programming language, very easy to use. The figure is very nice, super high quality, and then you export it into the LaTeX, right? And then in the LaTeX file, you embed your LaTeX native LaTeX figure, okay? Through this, you can achieve this result. And with this one, you achieve the same result for Python, okay? Why it is nice to have the native LaTeX figure exported and embedded directly into your paper as LaTeX comments? Because if you want to change something about your figure, maybe the label, maybe a variable there, maybe a symbol, you don't need to redraw the figure, but you just will go to the LaTeX document and you change that specific variable or that specific label and you recompile and you have the new figure done for you, okay? Without replotting with MATLAB, okay? That's the idea. Beautiful graphs can be obtained with all these programs. Spend time to build your own template for your environment of choice. Spend time to build your professional script. If you want to use GNU-block, if you want to use MATLAB or Python, this script will be used through the entire PSD to realize your prompts. And you can continue to update it. There are plenty of tutorials there nowadays. Use some time to improve your prompts and to read those tutorials that are available. Here I have some useful resources for you. You can go, and also by Giovanni Perin here, we have a suggestion of the right colors to use for the graphs. So there are also studies that are telling you what are the best colors for the reader to catch attention and also to be well readable when you print it, and so on and so forth. So there is a lot to know about this. This is an example that I found on the internet of a bad plot. Of course, this is not acceptable. And this is to show you how the same data can be, by some MATLAB processing, it is exactly the same data, can be re-plotted in a way that is acceptable for a scientific paper. So here you have, the fitting curve, there's dimensional data, confidence interval. Also here you have some confidence interval, experimental data. So this is, and you have a legend. In the legend, you're explaining the meaning of all the curves that you have here. You have the labels, the units of measure, and so on and so forth. Okay. Make sure that your graphs are all of the highest graphical quality. Wisely use the colors, making sure that all the details are clearly visible. There is a typo here. The standard colors such as red, blue, dark green are usually a safe option. Use encapsulated PostScript or PDF formats. Don't use JPEG or PNG. The legend of the graph should never overlap with the curves and with the points or the results, okay? You may enrich the plots with diagrams, curves, arrows, labels, and so on and so forth. Small plots, yes. small plots like this in a single column, they allow saving space. This has become pretty common because space is limited, even in journal papers, especially for experimental papers. But we are using a few tricks here. The colors, the legend is not inside the plot, but is outside of it to save space, and also in order for the legend not to overlap with the points. So we put it outside, we move it outside. We specify the units of measures here in the y-axis. The target is basically user ID, okay? So we squeeze the graphs in alpha column like that so that we save space and we can, we have a better use of the space of it. This is quite common. This is actually three graphs, three plots in the same, this is a full page, right? It's a double column paper, but on top of it, we use the full space available with this environment, figure environment where the three plots are basically horizontally placed in this way. Note that the legend should never overlap with the graphs. Note that the same range was used for the y-axis. They all go from 0,5 to 1. Why is that? Because this allows comparing the different results. It makes it easy for you to immediately grasp and understand the differences, okay? We are changing system parameters. Sometimes I see people, authors, plotting the same type of result with different, let's say, range for the y or x-axis, but the experiment is the same. Why are you doing that? I want to be able to compare things, right? Good. This is actually another way of plotting things, which we found quite effective. This is the experimental data with a little legend here. Those are the point that we detect from a radar, from the environment. Again, this is not the type of paper that I published, so yeah, this is what I showed. Anyway, to what we do from here to A to D, we explain to the reader the main steps of the algorithm, which is a clustering algorithm, okay? So basically, you need to be able to cluster the data points into sets, and we show to the this clustering procedure by basically identifying the center of mass of the points, a critical distance, and then we show also the refinement step. The clustering starts with circles, and then the circle will become ellipses because we are basically using some Gaussian type, of clustering algorithm, and so on. So basically, you see the points are the real experimental points. The arrow, the label, the circle, the ellipses, and the labels here are added on top of the experimental points to explain to the reader how the algorithm works. And also, in this way, we are able to explain to the reader all the subsets that are defined, how they interact with one another in the algorithmic design, okay, through an example, by showing to the reader what could be overlapping. So R1 and R0, they could be overlapping over here. What is the impact of this overlap, and so on and so forth, okay? So this is an example where we mix experimental data with our own drawing for the sake of explaining better what the algorithm does, okay? Voila. This is another example where we show the microdoppler signature that I have explained before of the user for different activities. So here we have empty room sitting, user sitting and walking at the laptop, walking, running, jumping. And you see that the signature is different. And of course, we can identify the activity, of course, through some machine learning algorithm. What is to be noticed here? The plots at the same y scale. Of course, we want to be able to compare them. The y-axis sticks, the y label, and the y scale are in common for all the plots, and they are only plotted once. They are only plotted here, and for this one are maintained. This is a trick because if you replot it also here and here and here and here, then the plot will be taking a larger space. And if you need to squeeze them in the page that is available, the result is that by adding all this data for every plot will make it so all the plot will be smaller. So by avoiding to repeat this data for every plot, the y-axis, the legend, the y-label and so on, what we can do, we can squeeze the plot more and we can plot them a little bit bigger. So it will be more readable for the final user on the paper, for the final reader. Is a trick. This is another example for a diagram. It's a processing pipeline, and you see that we are mixing the convolutional neural network. Basically, yeah, we are basically detecting an activity label starting from some reading, which is actually this type of signature. Okay, this is another possibility of how to go about a diagram to explain your technique. This is very important. References. Check whether a journal version of a conference paper that you have cited has appeared. Maybe you submit a paper to a journal. It will take 1 year and a half for the review process, and then you get it eventually, or possibly, maybe the paper is accepted, hopefully. And by the time the paper is accepted, you cited the conference paper there, but the same authors have published the journal version of that conference. Okay, check that and replace. It is recommended to replace the journal version instead of the conference. Sometimes this is what we do. Okay. At the same time, the same thing happens whenever you originally cited an archive paper because it was not published yet. It was only available on archive, right? But of course, you need to cite it because it's available openly. And you need to be honest and say, okay, this is existing already. They did it, it's on our site, not published yet, but it's available. Then by the time that your paper is accepted, check whether the archive that you cited maybe was published into conference or journal. If this is the case, update the reference with the published version. Also, be consistent in the way you cite journals, conferences, books. Always include the same fields for each category. So you need to use BibTeX. BibTeX is the package, LaTeX package to handle references. Use BibTeX, absolutely. Don't handle the references manually as we did in the past. This prevents you from making mistakes. Organize the references into bib files, which are the file that you are injecting into the BibTeX. And then you're compiling, and this is showing you the nice references at the end of the paper. Try to keep a collection of your bib files as you proceed through your research. Write them with care. And if you do so, you need to only do it once. By extending your collection of papers, maybe you can have a bib file on wireless sensing, a bib file collecting the papers on machine learning, one on wireless propagation, and so on. Okay, it could be you decide. Okay, but now we go to the important things. For each type of reference, journal, conferences, books, technical reports, you need to be consistent. And here, what I write to you is basically the information that I would like to see. For journals, usually I like to see the authors, the title, journal venue, the journal name, the volume number, possibly the month. You can decide whether to put it or not, the pages and the year. For conferences, also this information is what I would like to see. Usually for the books, this is what you need. For the technical report, this is what you need. The URL for the technical report, if it is available. If you're putting URLs for the technical report, you also need to indicate the last access date for okay, last time that you have been checking on the existence of this document or name, okay, at this URL. This is for journals. What is it here that you don't like? Can you tell me? Can you tell me something? You like it or not?
This one?
This one? No? Good. The problem that I see is that you see that we have a single pair of parentheses. When you compile it with BibTeX, this one will be compiled in a way that the only letter that is emphasized, that is capitalized, will be the A, the first one. The capital C, capital S, capital M, capital W, and all the rest will not be capitalized as a result of compiling this bib item. Okay. In order to make sure that you are getting what you see, so those S and C and M and W are capitalized, you need to put the double parentheses in front at the beginning and at the end. Okay, the double parenthesis will tell the LaTeX and the BibTeX compiler to preserve the capitalization. I often see references not well done. This problem is everywhere and also makes me upset. This means that you didn't pay attention. You didn't write this carefully. You didn't pay, you need to show commitment, dedication, and extreme care about all these details. So please do. Also, those are the fields that I recommend for a journal paper, which is article, bib item. If the number is not available, because it could be the number is not available by the editor, by the publisher, you leave it empty, no problem. So the double brackets that preserve the capital letters. For the titles, I often capitalize nouns, pronouns, verbs, adjectives, and adverbs. Okay. This is for conferences. In proceedings is a bib item field for conferences. Also here you see what I did was to put the we don't have the double brackets here, we have a single bracket, but this one we have a capital X and a capital A. I want to preserve it. I want to preserve the capital A, so what I did, I've been adding the extra parentheses around this word, X array, okay? The two extra curly brackets are ensuring me that this one will be showing up with a capital X and a capital A, okay? All the remaining words will be not capitalized, but I don't care because this is not capitalized, so I can do that. As an alternative, I can do what I did before, so put it at the beginning and at the end, and also in this case, this one will be capitalized correctly, and also all the rest will be capitalized correctly if there are other capital letters around. Okay, please do. Often this is proceeding off is omitted. I suggest using it, but this is not very important. The book title, which is a conference name, but this is the full conference name, can be shortened as, for example, proceeding ACM Nobicon to say space, right? Perfectly fine, especially for conference papers. But if you do it for one conference, you need to do it for all the conferences in the reference list. Okay, be consistent. If you do it for one bib item, you do it for all of them. Okay. What I don't like to see is that every reference that you have has a different style. The fields are different. In some conferences, you're putting the address of the conference, the location. In some others, you're not putting it. In some of the conferences, you're putting it here. In others, you're not putting it. In some of the conferences, you're capitalizing the letters. In some other bib items, you're not doing it. This is something that drives me crazy, right? Okay. This is for books. Again, you see, I have the double brackets because I want to preserve all the capital letters inside here. And this is a wonderful book, by the way, and you need to check out also. This is a genius. Bersekas is basically a professor on optimization theory, who has been teaching me a lot with his books. Now we have a new book on reinforcement learning, even distributed reinforcement learning from this book, and if you want, you can check it out. It's very nice. So for the edition, this is the data that you need to input for for the books, basically title, author, publisher, edition, year. For the edition, you can decide whether to go with for. You can use, instead of the parentheses, you can use abbreviations, or you can use even the number. Okay, it's up to you. For the outside for print, this is actually what I do, the fields that I put. Okay, and also with a note stating the last access date. Okay, acronyms. Possibly do not use the acronyms in the apps. If you need to, but try to not to use them too much. In the paper, I suggest that once defined, do not redefine them over and over again. Okay, it's annoying. So in order to prevent that, you can use later libraries that are there's glossaries or acronym. I like the acronym. I'm using this one, but you can also use the other one. So with these libraries, what you do, you have acrodef common, and you define your acronym. The first time that you use it, it will be appearing as full name with the acronym between parentheses, and then the second, third, and fourth time that you're using the acronym will be just appearing as an acronym. Okay, automatically. The library will fix it for you. Algorithms. Make sure that all the lines of the algorithms that you are presenting as a result of your research are numbered. Describe the algorithms in the text carefully in a human readable and understandable manner. Refer to the line number in the algorithm to pinpoint where the different functions are implemented, why, and how. Do not include an algorithm without duly explaining it in the main text in a human readable manner within the main text. What drives me crazy is it happened a lot, it is still happening, and authors saying, okay, explaining to you the general idea, maybe even with the toy example, you're all excited, okay, you have the toy example, I have understood what this guy is doing, very nice, I'm ready for it. And then it says, and this is the algorithm. Boom, 2 pages or 1 full page with the algorithm, maybe an explanation was like very short, and it is up to you to understand what it's all about. And this is not acceptable, of course. Okay? So never do that. If the algorithm is very long, a good idea could be to split it into subroutines so that you can maybe have 2 or 3 boxes by splitting the algorithm in several parts if it is too complex. And also, I'll show you what we do. This is an algorithm example. You see all the lines are numbered automatically. And then in the description, what we are telling, if we are explaining step by step what we do, why we do that, and where at this point the elements of this matrix are clipped to lie in this domain, in this subset, to avoid violating the transmitting power constraint in equation 26. And this is happening in line 5 of algorithm 2. However, blah, blah, blah. And then in algorithm 3, to make sure that the solution is feasible. So we motivate the things that we do. And also we constantly and continuously refer to the line number and to the algorithm that we are using to make this happen. Line 6 of algorithm 3 is adding perturbation until all the constraints are met in line 5. Okay? So we take the reader by hand and we drive it through the process. Okay? Try to do that. Also for the algorithms, what you can do, what you need to do is to use some LaTeX environments. We have those environments. Usually I use, it could be an idea to use algorithm, which is a float wrapper for algorithm. It's like the equivalent of the figure environment or the table environment, right? So begin algorithm and algorithm. The float wrapper will allow you to, it's similar to the table and figure environment. It allows to give an algorithm a number, a caption, and a label, and also to prevent the algorithm to split across pages. Okay. Okay, this is the framing environment that allows you to provide a caption, the cross-reference, the number to the algorithm, the label, and so on. So you do begin algorithm, end algorithm, caption, the label that you want to use for the cross-referencing. Then here you have your pseudocode. For the pseudocode, we are using another package, Latin package, which is algorithmic, for example. For example, you can use algorithmic, you can use algorithmic X. This is what I tend to use nowadays, algorithmic X, or there are also other options, but yeah, this is quite powerful. You can also create your own comments and your own special functions, let's say. Okay, so you can use algorithm as a wrapper, and for example, algorithmic X for the specification of the pseudocode. And here, this is an example of algorithmic X. You have a lot of comments that are available, that the state, get, procedure, and procedure, the while loop, the for loop, repeat, and so on, and even a comment, okay? For example, with this Latin code, you generate visually this result, okay? This is the pseudocode that is being generated, and this is actually showing you the if then else block, okay, how it works, okay? For example, this is another code example with algorithmic X for the Eclipse algorithm. With this code, you go here, okay? You see, this one is a comment. We have the answer if R is 0, and it will be commented, blah, blah, okay? Here I put the documentation for the algorithmic X is very well done. It's very well done in the sense that it's not only complete, it's also accessible, and I was able to get what I needed very, very fast. Okay. And I believe I also put, yes, some information link for the algorithm, and also that's it. Yes, for this too. This is another algorithm example. Again, I'm showing you what I said before, how to use the different lines, line 1, 4, 1, 3, and so on within the text, where we explain exactly what we do with this solution and why we do it in the way we do it, okay? Then a few final aspects, not so important. These are very, very tiny details, but this is also to explain to you that a paper has to be dealt with and written religiously, okay? Religiously means that you need to put a lot of attention and care in every single aspect of it, even in the graphical quality that you're obtaining, because this is also delivering a sense of professionalism, attention, care that you're putting into your writing, okay? This could be making a difference. This is a rant. It's a single word, lonely, tiny word in a row of text. If you can, it would be a good idea to avoid that. What I do to avoid it, I rephrase it somewhere so that we'll be scaling up and I get rid of the runs. There are also the widows. A widow is a paragraph ending line, like this one, that falls at the beginning of the following page. It's really ugly to see. Or column. And the orphan is a paragraph opening line that appears by itself at the bottom of a page or column, but separated from the rest of the paragraph. Okay, those things are not. The thing is that they somehow, in my opinion, degrade the comprehension of the text. So they basically the quality of comprehension from the reader. Because if I see something like that, and the rest I get to to go to the next page, I get a little bit lost maybe, and then I go back. What was page there? Okay, so try to avoid this thing if you can. This is not very important, but just to tell you, the level of care should be to the maximum level possible. This is a very simple comment. My students know that. This is my friend. Something like this is happening every time you have a composed name like that, Wi-Fi, with a dash in between, so LaTeX will be splitting it across possibly lines. So then if you write this one mbox Wi-Fi in this position, the result will be this. Okay, it will be avoiding the word to be split across rows. It's a little trick, a quick trick to obtain this kind of thing here. Right? It's much nicer to see. Closing. We are at the end of the seminar. I know it has taken some time, but I decided to spend this time with you today. So I did it consciously, okay? Because I hope it was useful, and then you will tell me. I can do it in an hour, but when I do it in an hour is a rush. Okay, I wanted to really deal with it properly. Use the time to learn the LaTeX you need. Not all the LaTeX possible, because this will take a full PhD. Did I spend days on LaTeX books? Never. I've been browsing the internet to understand how to use that specific comment in that specific way that I needed. Full stop. Spend time to have your own template for a paper. You can start from the IEEE official template for conferences and for journals. And then you can add up your functions, comments, tricks, all the things that you create for embedding equations quickly, the naming, and so on and so forth. So I have my own, let's say, templates that are not exactly the original from IEEE. They are those templates plus my own additional comments and things that I have created over the years to have a professional outcome. Okay. Work hard to get across your message. Text is very important. The graphs and the diagrams are also important. They need to be of the best quality. It is trivial to say, but it is like that. I need to say that. Don't take anything for granted. Don't assume anything. Rewrite your text. At the beginning of your career, you have your advisor, but it's also a good idea to handle your explanation, especially introduction and motivation abstract, the part where you're explaining the algorithm that are the most difficult. To handle this material to a friend or to a colleague, PhD student, who is not doing what you're doing, so he will be telling you, look, I don't understand anything about this, right? You need to rewrite it. It is easier for us when we are at the beginning to write technical things, equations, theorems, algorithms. It is much more difficult to write all the initial part of the paper where you motivate your research, when you explain the thing at a high level point, from a high level point of view, and when you give it to the reader with no example, in a way that you prepare the reader to understand the actual, hardcore technical part. This is the most difficult for you when you are a PhD student, is to hold this initial part of explanation and bring it by hand, taking by hand the reader so that they will be ready to understand the algorithm. The algorithm, maybe you are even better than me now. Okay, hopefully. So reorganize and rewrite your explanations. I'm sure the first time they're not yet to the point. Take your time. Rest, somehow intend. Don't only spend time in working, but also enjoy yourself in life. This will help cleaning up your mind, and then you will be getting back stronger with better, even with the better explanation. Critically analyze the good paper that you read and try to adopt the tricks that you see there, the presentation style that you see there into your own writing. This is what I did. Also, this is a recommendation that I found useful for me. Start writing your mathematical analysis early on. Sometimes you're developing things on papers and then your model and so on. If you take your time to to write it down nicely, as you would do in a research paper. Maybe it's not yet finished, but you pay attention and you pay an effort to formalize it automatically in a LaTeX file, as it would be the central part of your paper. And maybe you get stuck because you haven't solved it entirely, but I'm sure that the process of doing it will be unlocking some comprehension, some understanding, and for me, it worked well even to understand how to move on sometimes, okay? How to overcome some obstacles, some technicalities that I couldn't solve, by just taking the time to put everything in order, selecting a notation, the variables, explaining the mathematical details in proper order and consequential and logical manner. All the process was very useful, even to unlock some final steps of the analysis. And also, as a byproduct, if you do that, the central part of the paper will be ready, because when you finish, you will only have to write introduction, related work, and all the rest, but the technical part, you are developing it as you go, and it will be ready and well done, almost, immediately. Also, receiving a rejection is normal, never give up. Use the feedback, the good part of the feedback, to improve your work. And also sometimes what at the first sight seems unfair or bad news for you carries opportunities with it. This holds in general, not only for papers, but also in life. These are the papers that I use for this lesson. These are all from me, so all the material is for from my own research. And this is the end of the talk. Thank you so much.